Hello everyone, and welcome to my presentation, which is titled Best Financial Prediction Model for the Tesla stock. So here's the situation. The stock market has always been an area of great interest where buyers and sellers meet on various platforms in order to exchange equity shares on public corporations. And according to a Forbes article, the finance and investment sector has the #1 spot for producing billionaires. Technology coming in second, manufacturing coming in third. Because of the high interest in this area and the potential to make huge returns on investments, people and companies are always looking for a competitive edge. Stock market prediction models using machine learning can help with this. So we're left with the question, which machine learning model is best for stock market price prediction? More specifically, for the Tesla stock. And in this project, and captured in this presentation, are various machine learning models that were tested against one another to try and find the answer to this question. Before we start delving into which models we could use, first we got to get familiar with our data. The data comes from two of the largest providers in the world for stock market data, and that is Quandl and Quote Media, and they both come with their own Python library, which makes it easier for extraction. Taking a look at the snippet, we can see that the data comes with 12 columns and about 1900 rows, which each row is a daily entry of the financial information for the Tesla stock. That includes the open, the high, the low, the close, the volume, etc. It's worth noting here that the columns split ratio and X dividend were excluded from our models, and this was due to the EDA process that was performed in the Python code, as they provided literally no correlation with any other of the columns, so it wasn't going to benefit us to keep them around. So for the methodology, it's a pretty simple approach. We collected and explored the data. Like I mentioned earlier, we just excluded some of the columns because they provide no benefit. We then tried the different models, and the different models that were checked were linear regression, random forest, support vector machine, Bayes ridge, k-nearest neighbor. Then we analyzed the different models on the Quandl and Quote Media data, and then we interpreted the results. It is worth mentioning as well that the support vector machine model was excluded early on. This was due to the low performance as compared to the other ones, so it was kind of a quick process of elimination, so to speak. A couple notes for the data sets and the models is that the adjusted close column from the data sets was used as a target column to predict on. You would think that we'd be using the close as the predicted column, but we are using the adjusted close because that takes into account any corporate actions such as stock splits. So if you take a look at the top and bottom graphs, the stock split adjustment is the one on the bottom. And you can see that there's a huge difference in the range of both of them. So now that we had a chance to talk about the data and some of the models that we're going to be using, the next thing to consider is whether we have a regression or a classification type problem. And it's easy to see that we don't have a classification problem because we're not trying to find out whether the stock price is going to be higher or lower. We're trying to find an actual value, so to speak, and how well the models can predict that. And so with regression type problems, we are left with very few metrics that we can use to evaluate. And that includes the mean absolute error, the mean square error, and the root mean square error. And in general, the lower the value indicates, the better the model. So the next two metrics that were used to evaluate the models are R-squared and accuracy, but they should be taken with a grain of salt. For one, R-squared takes no consideration for overfitting, and accuracy is a metric that's used for classification, but it is used in our regression models to get a simple idea of how they're performing by showing how accurate the model is at predicting the next sequential value. So a couple things to note before we get into the results. The Bayes ridge is basically a naive Bayes approach to regression. For the KNN model, it was tested for performance on standardized and normalized data. KNN models are typically perform better on normalized data, so I wanted to showcase that a little bit. For SVM, as I said earlier, it was excluded early on due to poor performance. And while we will see in the results that Bayes ridge performed terribly, I kept it around just to kind of showcase a bad model. For random forest, a hyperparameter tuning method was used to find the optimal configuration for the model. So here we have a table form of the results of the different models, and these are broken down by quote media data set and quantal data set. And we can see that we have the models in the columns and the different metrics in the rows. So if we're just looking at the quantal data set, we can see that the MSE and the RMSE are lower for the random forest, and it's the same thing in the quote media data set. It does look like linear regression performed better than random forest, but due to the different techniques that were used, linear regression was definitely having an overfitting issue, whereas random forest did not, because we incorporated the hyperparameter tuning and cross-validation. So this slide just basically discusses what we talked about in the previous slide, with the addition of the standardized data on KNN appearing to have performed better than normalized data. But at k equals 2, there was a strong chance of overfitting, and thus that's why we chose to go with the KNN that had a higher k value. And so the top two choices were KNN normalized with a k equals 7 and random forest. But obviously in the end, random forest is the model of choice, and that is because of the significantly lower error values that we got. So in conclusion, the project and presentation highlighted some of the most popular machine learning models, and we tested them against one another to see which one performed better on predicting Tesla's stock market price. The different metrics helped us to evaluate these models and determine the best one. And the best one of choice ended up being random forest, and as it performed better across both data sets, and that was thanks to the mix of hyperparameter tuning and the cross-validation, which helped to prevent some overfitting. And that definitely gave us the confidence in that model. So that is it for my presentation. Here is a list of references for some of the information that I grabbed. And if you have any questions, please feel free to reach out to me.